chapter. And I'm going to ask Scott Yale to open us in prayer. Scott?
I'd like to open us in prayer tonight by reading the last verse of Psalm 19 because it's significant to what we're talking about tonight. It's very short, so if you would bow your heads with me. Lord, may my words and my thoughts be acceptable in your sight, O Lord, my sheltering rock and my Redeemer. Please bless this time that we have together, Lord, and allow us to speak truth and to have it sink deeply into our hearts. We pray these things by your Son and through your Spirit. Amen.
Thank you, Scott. I am going to go ahead and introduce our speakers tonight so they have the bulk of the meeting to bring the presentation. We have two chapter officers who have collaborated on tonight's talk. Gabriel Dink is going to be covering the scientific topics of planet finding, habitability, and astrobiology. Gabriel has a Bachelor of Science in Computer Science and Engineering from Materno University. He works as a design engineer for a small design services firm in Plano. So if you are looking for somebody to help you build a fusion-powered supersuit, he is probably the most qualified person in this group to do that. Joining him also will be Scott Yale, who is covering extraterrestrial hypotheses, UFOs and RUFOs, IDH, and theological ramifications of those. Scott has a Bachelor of Science in Psychology from what school?
Columbia
University. And he has a Master's of Theology from Dallas Theological Seminary. Please help me welcome Gabriel and Scott.
Good evening.
Hey.
So I was inspired to bring this topic by recent headlines and chatter and a lot of people's interest in this subject. So the question is there anybody out there?
Anybody out there?
Pink Floyd is a little bit out there, but that's not what I meant.
Good.
NASA's been in the news a lot lately. They've been doing planet finding and releasing lots of press releases that are getting a lot of discussion. Mars, the wet planet, conjures images of babbling brooks and flowery meadows. Earth twins and new planet discoveries and the inevitability of finding life out there eventually. And so this has very important implications for Christians and for apologists. Here's an article that appeared recently in the Huffington Post. Here's an excerpt from it. This author said, Earth 2.0, which is the Kepler 452b, is a huge, if underappreciated, discovery. Not because Kepler 452b is unique, but for just the opposite reason. There are likely thousands or millions or even billions such Earth-like planets in the universe. With this discovery, we come ever closer to the idea that life is common in the universe. Let us be clear that the Bible is unambiguous about creation. The Earth is the center of the universe. Only humans were made in the image of God, and all life was created in 6 days. All life in all the heavens in 6 days. Well, I guess 1 out of 3 ain't bad. To be clear, we're talking here only of how just the simple existence of life elsewhere undermines all religion. This author believes that finding extraterrestrial life undermines all religion, and obviously he's singling out Christianity. So what about these headlines? I don't know if you heard of, it was in July that the Kepler 452 was discovered, and recently there was an announcement of a possible alien megastructure discovered orbiting star KIC 8462852. Yes, here's the Huffington Post. It was October 19th, 2015, that was published. So what about efforts at directly finding extraterrestrials? Well, that brings us to the SETI Institute. Now, the SETI Institute has been operating for several decades. Frank Drake made the first radio telescope observations or experiment in 1960. So for 55 years, the SETI people have been listening to the radio waves, hoping to hear traces of reruns on ET's television or whatever's going on there. This is a familiar image. This is the Arecibo radio telescope, or radio observatory. It's a 300-meter wide dish that is one of a few large radio telescopes that the SETI Institute has piggybacked on. Basically, they have put a little bit of their equipment at the site to get more information from the radio signals that other astronomers are gathering for other purposes. As you can imagine, the funding is a little bit short for these folks, and so they have to be efficient. This particular radio telescope has itself scanned 20% of the sky for the SETI Institute. And so what have they discovered so far? I have a slide just for that.
Is that white noise?
Here's something. Oh, no, that's just a mark on the screen. Never mind. Yes, so they found a lot of noise. Some is things that seemed interesting, but only to those who are very, very excited about it already. So we haven't found anything. Nothing positive. Oh, and to be fair to these folks, their capability of detection so far is really only capable of detecting radio signals that are intentionally beamed toward Earth. If they've just got radio stations going, it just isn't strong enough for us to pick it up, most likely. So really, ET could be out there for all the SETI people know, and it's just we haven't searched very much, even though they've spent many, many hours on radio telescopes. So we haven't found anything. So is life out there even possible? So let's look at the demands of life. NASA has a short list that they use for press releases, and also because what we are able to know about exoplanets right now is very limited, and so understandably their list is short. So here are the requirements that they typically point out to. So for a planet, it's got to have liquid water, although I would say it probably needs to be surface liquid water. They're not quite that picky. It has to have a rocky surface, so gas giants they're going to rule out. It has to be Earth-sized, which to them means half the size of Earth up to maybe 4 or 5 times the size of Earth are interesting to them. And for the star, they're looking for something that's relatively stable, no obvious, enormous flaring events and that sort of thing. It's got to be a solar star. So NASA recognizes that binary star systems involve too many gravitational perturbations to have any life support body orbiting them. And they're looking for stars that are sun-sized. So basically looking for main sequence stars that are in the same basic class as the sun. So Reasons to Believe has a somewhat longer list of requirements that they have, that the scientists there have put together over the years, that are requirements that must be met for life as we know it to exist on the planet. And so these are the reasonable requirements. They are. It's a fairly conservative list. So. This is the Reasons to Believe Design Compendium, if you want to look it up online. Compiled in 2009, or last updated in 2009. Okay. Sorry it's so long. Each one of these lines is a whole different requirement, by the way. Okay, we're getting there. I appreciate your patience. Yeah.
I guess it's a good
The
thing
entire
that's the short
soundtrack
list.
playing.
It's almost there.
Yeah.
We could share all of those.
It's getting close.
Okay, so this list includes things excluded from the NASA list, like the star's proximity to various supernovae and hypernovae events, the star's metallicity, rotation rate, and even some more obscure things like this is a quote, strength of magnetocentrifugally launched wind of parent star during protostar era. Yeah, see that 3 times fast. I had to practice it.
Oh.
Oh, that list was just for the star. This is for the planetary system. So, begging your patience. Yeah, so has to do with where the gas giants are, where the mass is, and asteroid belts and Oort cloud analogs, that sort of thing. I see gamma ray bursts in there. Outer planetary disk lifetime, magnetization. Okay. So as you can see, it's a very long list. Reasons to Believe has about I think it was 800.
Oh, don't forget these.
Oh. Okay, so these are for the planet.
It's probably a long list.
Compared to NASA's.
Yeah, see, we thought about making NASA's list into a movie, but it was all you got is ta-da, and it was done. So, if we have any speed readers in the group, they're welcome to take this in. Okay, this is for the moon surrounding that orbits that star, and the planet's surface. Now, in this list, I intentionally avoided additional parameters that have to do with the galaxy and the galaxy cluster, because obviously all of our attempts to find exoplanets and look for extraterrestrials have to do with being in our own galaxy. We can't detect anything beyond that, and so obviously our galaxy is the just right galaxy already, and so I left those off. The Reasons to Believe list has 816 parameters that must be fine-tuned for the planet, star, galaxy, and galaxy cluster together. Their online compendium is backed by 658 bibliographical references. It's almost as many references as there are items in the list. And there's an additional 140 requirements that are for the universe, which aren't relevant to this talk of extraterrestrial life, but just so you know it's there. 140 parameters, fine-tuning for the universe. Has to do with things like gravitational constant and the ratio of various force constants, that sort of thing. So life as we know it would seem to have lots of requirements on it that are not met by what we see out there, and that are very stringent. So the comeback to this is always, well, what about life as we don't know it? What other kind of life could there be out there? And the charge that's often leveled is, you just don't have very good imagination. You're assuming that we're trying to get human beings and human civilization moved somewhere else. Well, the sky's the limit here. All different kinds of things could be. So I'm going to look at just two materials that we consider important to life, and see if they are really unique. NASA's philosophy for looking for life outside the Earth is follow the water. So let's see if they're justified. Water is a very unique material. It is a universal solvent. It's a polar solvent. It has a wide liquid range for a very unusual reason that I'll mention in a minute. And so you have because life as we know it, and any kind of life, is going to require a liquid medium in order to exist. A solid medium doesn't allow enough movement of materials and nutrients, and a gaseous medium is just too dispersed. You can't get enough material together. And so it's going to have to be liquid. And so you need a solvent for life that can remain in liquid range over a wide range of temperatures. It exhibits the hydrophobic effect. This is the oil and water principle, and is critical for many life processes, including the formation of cell membranes and the proper folding of proteins. Proteins include areas, certain amino acids are hydrophilic and others are hydrophobic, and so in the presence of water and lipid materials, it will fold in a certain way as it attracts or repels these different sections. Water is unusually sticky. Now, I have a toddler at home, and so usually when I think of sticky, I'm thinking water is going to fix the sticky. But water itself is sticky. It has some very unique properties where water will sort of cling to itself, which greatly increases its surface tension and capillary reaction, which are also very important for life. As you can imagine, plants need very strong capillary reaction to pull water up inside them. And the reason for that, I came across Today's New Reason to Believe a few years ago, that the structure of water and what makes it sort of cling together like this requires that certain quantum mechanical principles be exactly in balance. In other words, the physics of the universe had to be fine-tuned in order for a solvent like water to exist. Water is a ligand, which means it can bind to metals, also important. Water can carry out hydrolysis, which means it can break chemical bonds in other molecules and thereby changing them into building blocks for something else or release energy. It can function as an acid or base, so it has that versatility. It is an electrolyte, so you can add trace amounts of some familiar nutritional materials like potassium, sodium, magnesium, and it will transport electrons. It also exhibits hydrogen bonding, which is a type of molecular bond that's also very important to life. The other material that we normally think about as life is carbon-based. Does life really have to be carbon-based? Well, carbon is unique. It forms 4 chemical bonds, which any silicon will do that, and other materials in that same column of the periodic table will do that. But not very many materials, elements will do that. It is extremely versatile. This is a key. To get any kind of imaginable life, you need a basis for that chemistry that is extremely versatile. It can make all the different molecules needed for living things. Carbon can form more than 10 million compounds. In fact, I heard a story of a chemistry who taught a story of a university professor who taught a class in organic chemistry. And it was a undergraduate class, and the final project in that class was every student had to go out and invent a new organic compound that had not been seen before. And year after year, every student can make a whole new compound. Now, it may not be very useful, but it's a new compound. Just for sake of comparison, silicon can form maybe 20,000 compounds. Extremely versatile, but 500 times at least less versatile than carbon. Carbon is very stable in the bonds that it forms. It can form polymers, these long molecule chains like DNA, and I think proteins would be in that same class, of virtually unlimited length without becoming unstable. Silicon cannot do that. So beyond, I think it's just maybe a couple of hundred links in that chain, silicon polymers become unstable. And carbon is unique in that it forms stable aromatics. Now, I'm not talking about perfume. I'm talking about these ring-like structures as in a benzene ring. These ring structures and molecules are important for many biological materials or compounds, including some that you may have heard of, like chlorophyll and hemoglobin. So that's what life requires, and we realize that life as we don't know it isn't going to be that foreign. If it's water is its solvent and it's based on carbon, it's going to have amino acids, it's going to have proteins, or something very similar to that. So what do we actually see out there? When we've had all these NASA discoveries come up, what's out there? Well, we've confirmed discovery of 1,903 exoplanets so far. That's huge. 30 years ago, I think it was one. This is a field that has really taken off. And here's the detections by year. So as you can see, that doesn't even show up in 1989. And I think there's a half a pixel worth or something down there. And 2014 was the year of detections. This is when the Kepler mission released a bunch of their findings. And 2015 looks like it's been kind of a bummer, but what's actually happened is a lot of the detections from 2014 were confirmed in 2015. I think it's been over 800 confirmations from other methods. So a lot of this has come out of the Kepler mission. So there's the Kepler Space Observatory, which is in solar orbit, not Earth orbit, and it points in one direction. It just sits there and analyzes the light from about 150,000 stars, looking for transits. And there's a diagram of what a transit looks like. So if we just happen to be oriented in such a way that the Earth is lined up with the orbital plane of a planet, then we can see the light of the star dimming slightly as the planet goes between the star and us. And so what they are analyzing are these light curves. And so they see the light of the star actually has a little bit of bumpiness from instrumentation, noise, and from actual variation in the star's brightness. And it'll dip slightly. And so in order to make sure that that's really a planet, they want to see it dip again and see if it's a regular pattern because an orbit will have a periodicity to it. Now, of course, this can only detect planets that are lined up with, or that are periodically lined up with the Earth, which is about 1 in 210. So we can guess that for every planet we find, there's another 210 that we can't see by this method. The light dimming in this light curve, where it shows the light dropping slightly, that's on the order of 0.01%. You can imagine that this Kepler device is a very sensitive instrument. Another method for finding exoplanets, because you can't actually see the light from most of the planet unless it's very close or very large. So, but the a planet going around a star causes the star to wobble because the center of mass of the star-planet system, or the rotation must be around the center of mass, and the center of mass becomes slightly off-center. There's a planet orbiting around. And so, if we're looking at it this way, if we're looking at sort of the broad side of a planetary system, we will see that star moving in little tiny circles. This is called the astrometric method. If we happen to be looking at an edge on, we can still use this method because the host star will be moving toward and away from us rhythmically. And so we can look at basically the Doppler shift of its spectral lines. And that's called the radial velocity method. So how does the Earth compare with what we see out there? So Mars is in the news a lot, mostly because it's the nearest rock, it's the only rocky planet we can really measure that anybody has any idea that there's life on. Well, it has no water. Well, almost. NASA touts that there's water on there, but it has ice caps, small ice caps. Well, frozen water doesn't count. And the liquid water that they found recently is in very short supply. There's not enough of it for life. And it is contaminated by strong concentrations of these salts that are, it's like bleach. It's like bleach water up there. It's concentrated, and it's like a disinfectant. So interesting, fascinating, but doesn't really help you if you want anything living there. It has no stabilizer for its tilt. So it has two small moons, Phobos and Deimos, but they're too small for their tidal interaction to stabilize the axial tilt. So Mars is, it'll be nearly upright, and it'll tilt way over 40 degrees, and that would cause climate disruptions that would destroy life. The Earth has this very unusual large single moon that stabilizes the tilt axis, so it's sitting right there at the 23.5 degrees and varies only slightly over long periods of time. Mars has no plate tectonics, at least not for the last few billion years. Plate tectonics are necessary to recycle nutrients to the surface, to counter erosions if you ever want mountains and ocean basins and continents and that sort of thing, which are also important. It has no magnetic field to protect against cosmic radiation and other things. At least it hasn't for the last few billion years. So, now a caveat here that Hugh has pointed out, that we probably will find the remnants of life on Mars, but it will be Earth life. And in Lights in the Sky and Little Green Men, he says, over the past nearly 4 billion years, several million kilograms of Earth life remnants must have been deposited on Mars. That's through asteroidal impact blasting stuff into beyond escape velocity. It seems only a matter of time before researchers detect and possibly misconstrue its presence. So if we get samples and confirm some kind of microfossil, it will be headlines everywhere, but don't get too excited. It's probably just Earth life that made it there. How about moons? Moons in our solar system, there's speculation that Enceladus or Europa may harbor life. Well, the thing about the moons around these gas giants is they're very cold. So liquid water is unlikely, although there's possible that subsurface oceans could exist because of heat from other sources. Very dark. So even if there's some kind of bacterium living on that planet or on that moon, there's no possibility of life on the surface, no possibility of photosynthesis, no new energy, no new nutrients. It's going to run out of fuel and die.
Because the
So-
atmosphere is real thick?
No, there's virtually no atmosphere on So the only place you'd have liquid water is deep under the surface, where tidal heating and maybe radiometric decay are keeping it warm enough where it doesn't freeze. But what we find is that although life below the surface on Earth is abundant, and there's been a lot of surprising discoveries lately about that, it ultimately, for its long-term existence, relies on surface life and nutrients sort of filtering down to them. So these objects are basically dead.
How about volcanic activity on some of the moons we read and hear about? How do we look at that?
Well, like Jupiter's moon Io is the most volcanically active body in the solar system, but it's very volcanically active. It's very unstable, and so if you want life, especially advanced life, to exist for any period of time, you've got to have the stability, and you have to have and actually just heating the planet, you'll get liquid water, but heat is not a usable form of energy. So the only thing that anything could eat there is going to be minerals, chemicals. There's a type of bacterium called a chemoautotroph that can just directly metabolize minerals, and that's all you'll get. But they will die out if there's not photosynthetic life on the surface, putting energy back in from light, which is a usable energy source.
Take it from Mars having no tectonic plates. Can you assume then that its center is not hot, molten?
Yes.
Okay, which means, say, at the Earth center is hot because it's populated with radioactive thorium, uranium, which came from a supernova. Somehow that bypassed Mars and ended up here, which is very interesting.
Right, which has to do with the moon formation theories, that the disk of material that coalesced into planets, you would expect to get similar concentrations. Now, being closer in orbit, we might get a little more heavy materials. I'm not sure how that works, but the planetary formation theory would say that we have far too much of those heavy elements, radiometric elements, on Earth than we should have. And so the theory is that we basically gained all of the heavy elements from this Mars-sized collider that hit the Earth and kind of formed the moon. And so the light materials go to the moon, and we get an extra enrichment of the heavy materials on Earth. So how about this Earth twin, Kepler 452b, made headlines in July. It's about 1,400 light years away. So here's the good news: it's in the habitable zone. Its distance from its star is only slightly more than the Earth. It has a orbital period of around 380 days. It's Earth-sized by NASA's definition, which it was detected by a Kepler, obviously, from the name. And so all we know is it's how big the disk of it is. So we know the radius, and therefore we know the volume of the planet. Well, it turns out to be 60% larger in diameter, which if you cube that, it comes out to about 4 times the volume. According to the Reasons to Believe Design Compendium, well, I'll get to that in a minute. So it's Earth-sized, got a rocky surface, probably. That's just an inference from what they know about planetary system formation. And the host star is a G2 type, which is the same as the Sun. Its mass is about 10% larger than the Sun. But then here's the wet blanket. Okay, it's 4 times the size of Earth. The design compendium says that the mass parameter must be fine-tuned within 0.1%. And in the discussion time, I can bring up the explanation they give for why that has to be fine-tuned. I think it has one of the reasons it has to do with escape velocity of various materials. So some things you need to escape into space, and other things you need not to. And so the mass has to be fine-tuned. and likely has an ultra-thick atmosphere, because the same planetary formation theories that would tell us that it has a rocky surface also said it's going to have an atmosphere that's going to be thicker, quite a bit thicker than what we find on Venus, and that atmosphere on Venus makes Venus uninhabitable. The star is 6 billion years old, roughly. That's 1.5 billion years older than the sun. That's a parameter that needs to be fine-tuned to within 0.01% because of the star, the life processes of a star, that it's only stable and only has the right kind of radiation and so forth during a very narrow period of time in its middle age. The metallicity of the star is 60% higher than the sun. That's a parameter that Reasons to Believe points out as needing to be fine-tuned to within 1%, not 60%. And that has to do with the metallicity is the amount of heavy elements in the star. Heavy elements in the star mean heavy elements in the planets orbiting that star that formed at the same time. If there's too many heavy elements, you have all these poisonous things that are, the heavy metals that we're always worried about getting in our food by accident. And it also means a lot of radiation.
Question. Being we're this far away, how do we detect a thick atmosphere, much less an atmosphere at all?
On this one, we don't.
Mechanisms for doing that?
What we know about the atmosphere of this particular planet is just inference based on planetary formation models. So if we know how big the planet is, what kind of star it is, we're going to guess. But those same models say that the Earth should have an atmosphere thicker and more poisonous and more problematic than Venus.
So
But we
we're
don't.
able to make an assumption based on some of the variables that we.
It's an assumption, but
Okay.
it's in the realm of speculation. I wouldn't hang too much on it. Now these planets detected this way, we are seeing the planet in front of the star, and so it's at least theoretically possible to do spectroscopy on the atmosphere of that star. But it's just, as I understand it, the technology is not there yet to see these from 1,400 light years away.
Thank you.
Maybe a lot closer, but yeah. So that's one of the reasons the NASA list is so short, is because all the rest of these we can't test on any but on Mars we can, on Enceladus we can, on Venus, whatever. But outside the solar system we can't measure these. But we can tell that there is variability. Just looking at our own solar system, we can see that these parameters are not all fixed. They're not driven to some value by unknown mechanism. And we can tell that they need to be very fine-tuned. And therefore, if you're just rolling the dice, most of the time it's not going to be inhabitable. And at this point, I will hand it over to Scott.
All right, that was fantastic. Thanks, Gabriel.
What is your picture of?
The sky.
This guy.
Yeah.
Don't you
Is that
see the
the-
portal?
Highly unlikely.
Who knows? Okay, man, is that guy brilliant or what? I mean, for real, that was amazing. Thank you. So, what discussion about life in the universe would be complete without discussing the possibility of UFOs? So that's what we're going to do. We're going to do some examination here. So, a little bit of history. People since antiquity have been seeing things flying in the sky and wondering what they were. Unusual and inexplicable things. Flying entities often come in waves. And interestingly, just before man's transition into the skies, there was a wave of sightings of these things. Also, during World War II, both Allied and Axis pilots report seeing entities that would shadow their airplanes and follow them and keep pace with them and do unusual things. And interestingly, both sides thought that they were secret weapons that the other people had developed. They even had a name for these things. You may have heard of them before, or at least you've heard the name. It's called Foo Fighters. that interesting?
Huh.
I'd never heard that before. Now, the second half of the 20th century has been dubbed the Age of the Flying Saucer. And more precisely, at 3 o'clock p.m. on this date, let me see, I got the date here. Oh, I guess I've been going through, there it is. On this date, June 24th, 1947, at 3 o'clock p.m., Private pilot Ken Arnold, while flying his plane near Mount Rainier, Washington, observed 9 bright boomerang disc-like objects traveling at incredible speeds. And this has become known as the introduction or the inception of the flying saucer age. Now, for national security reasons, the government, of course, became interested in this emerging flying saucer phenomenon because could they be advanced Soviet aircraft? Maybe. Could we, our military, perhaps benefit from some sort of alien technology if these are visitors from another planet? So the Air Force launched several investigative projects culminating in what was called the Condon Report, which contained the following. The emphasis of this study, this is towards the end of it, the emphasis of this study has been on attempting to learn from UFO reports anything that could be considered as adding to scientific knowledge. Our general conclusion is that nothing has come from the study of UFOs in the past 21 years that has added to scientific knowledge. Careful consideration of the record as it is available to us leads us to conclude that further extensive study of UFOs probably cannot be justified in the expectation that science will be advanced thereby. This lack of information from the government gave birth to all kinds of conspiracy theories and suspicion that the government is covering something up. I don't know how many people in this room, what sort of types of people you are. I'm guessing most of you are probably skeptics. That's how I would describe myself. And Hugh in his book, Lights in the Sky and Little Green Men, covers a variety of people because there's people that really truly believe this stuff, and some for good reason, which we're going to discuss actually in a minute. So what are they? These phenomenon that we have experiences of seeing. Well, some of them are natural phenomenon. I can remember in Wisconsin, I was living in Wisconsin, and I, along with several hundred other people, including the news media, by the way, they had pictures of them, saw lights in the sky. I can't remember how many there were, 5 or 6 of them. Moving around and then, buzzing off or something. And I think the news media had pictures of them and showed them, and I think it ended up being some sort of a natural phenomenon. I'm not sure exactly what it was, but it was, gas in the atmosphere or something. There's also man-made phenomenon, right? Lights reflecting off of aircraft, or just at night, it may be a light off of a airplane. Perhaps it's some sort of secret government project. There's been many sightings around Area 51 and around the Skunk Works in Nevada, where they, have tested secret military aircraft like the Blackbird and the stealth bomber and that kind of thing. Excuse me. There's also hoaxes. People who seek attention, obviously, love to get in on the act, and so they create hoaxes and attempt to deceive people through their actions. Ultimately, these 3 categories really become what are called IFOs, or identified flying objects. They have a naturalistic explanation, and so 99% of all cases become IFOs. And there's some legitimate UFO scientists that actually study case by case each example. And like I said, like 99% of these end up being IFOs. The other small percentage of these are called RUFOs, or residual UFOs. That's what the R stands for. And these are perhaps the most interesting ones because they have credibility to them. When I was a young man in Colorado, there was a period of time where there were unusual things happening. There was cattle mutilations. And these were strange, and we're not going to really talk about cattle mutilations. I actually did some research on it for this talk because I was just interested, because I wanted to go back and revisit that. But these cattle would end up having some of what looked like surgical cuts on them, and surgically removed organs, and unusual organs, eyes and rectums and different organs. Strange things had happened. And one of the strange things was they were missing blood. They virtually lacked any blood left in their body. And this was a kind of a hot topic in Colorado. It's a lot. I grew up in a ranching sort of a community. And one night, my best friend was over. We were young, probably 7 or 8 or 10 years old. I can't remember. Walked out. My mom told us to go take the garbage out, and we walked out. The garbage cans happened to be out by there was a fence right behind the garbage cans, and there was a cattle field right behind that. And as we threw it was dark, and we threw the garbage into the garbage can. Suddenly, in this field, there was a funnel of light that came from somewhere where you couldn't see, and there was nothing above it. And for little kids, we were scared to death. And that's my UFO experience. I'm just throwing it out there. It's anecdotal. I don't know to this day what on earth we saw, because we turned around and ran into the house as fast as we could. Because, we had these, we were just thinking we were going to get sucked up into whatever that thing was.
Right after you ran, that's when all the people started laughing.
Right, exactly. So is there really video evidence in support of extraterrestrial life? Absolutely there is. You guys may have seen some of this video evidence. If you haven't seen that, you've probably seen that guy's ears there, I'm guessing. So are UFOs, what are they? Well, there's different theories, and that's what we're going to spend a little bit of time talking about. First is the ETH, which is the extraterrestrial hypothesis. That's what most Americans think of when they think of UFOs and outer space beings and aliens, is the extraterrestrial hypothesis. Well, contrary evidence with regard to life's origins and alternative life sites virtually destroys the plausibility of the extraterrestrial hypothesis. Thank you very much, Gabriel, for dashing our hopes.
Anytime.
Hughes, in this compendium, he says there is less than 1 chance in 10 to the 1,032nd exists that even one such life-supporting body would occur anywhere in the universe without invoking divine miracles. And we're going to talk about some probabilities here in a minute. So just for now, just trust me when I say that this number is very large that Hugh's talking about. There's not only to mention that, but the evidence that our UFO phenomenon seem to be non-physical, both in origin and nature. So let's, this is, turn that up a little bit.
I like you a lot. I want to ask you a question, straight out, flat out, and I want you to give me an honest answer. What do you think the chances are of a guy like you and a girl like me ending up together?
Well, Lloyd, that's difficult to say, and you really don't...
Hit me with it. Just give it to me straight. I came a long way just to see you, Mary. Just, least you can do is level with me. What are my chances?
Not good.
You mean not good, like 1 out of 100?
I'd say more like 1 out of a million.
It's not zero.
One thing I noticed among UFO aficionados was the fact that this is a tremendously large universe, and because of that fact, there has got to be other life out there. Because if there's one chance in a million, it's just got to be there. So we're going to talk just a little bit about probability. There's something called the single law of chance. It was developed by a French expert on probability called Emile Borel. And what Emile Borel found was that one chance in 10 to the 50th, which is a number that looks like this number on the screen, means, one chance in 10 to the 50th, means there is never, ever, ever, ever a chance that that thing is going to happen. In other words, one chance in a 50th is the same as zero chance in a 50th. It will never happen. Okay? Texas Mega Millions is about 1.7 in 10 to the 8th, if that gives you any idea of the size of this number. It's incredibly large. And I want to share a larger number even than that, but much, much smaller than Hugh's number. And it's 10 to the 171st. I got this out of a book called Darwin's Leap of Faith. And I think you're going to enjoy this little exercise. If you'll look at a book the next time you're reading it, you'll see the period at the end of a sentence. It contains about 3,000 trillion atoms. Okay? 3,000 trillion atoms. Our universe, for argument's sake, and we'll just have to agree on this because I didn't bring my measuring tape, but we're gonna assume that the universe is about 30 billion light years across from end to end. Okay? Is that reasonable? Can we all agree on that? Sure. Is that okay, Phil? Okay. Now, what I want to do is I want to take 600,000 trillion universes and line them up end to end, okay? Each one being 30 billion light years across. We're going to line up that many universes across, okay? Are you with me still? I know it's hard to... Now, we're going to take an amoeba. Let's call him Bob, if that's all right. Okay? Now, Bob is not the fastest amoeba in the room. Okay? Bob only goes 1 inch every 15 billion years. 1 inch every 15 billion years. Okay? That number, is 10 to the 171. That's how big that number is. He will travel across those universes in 10 to the 171 years.
So where do the 3,000 trillion atoms come in?
He's going to carry each one of those across that many universes. 3,000.
So
he's going to go pick them up and carry them across.
One at a time.
One at a time. That is a crazy large number, right? So that's why, and the reason I want to talk about that, and the reason that we had the example earlier of Hugh's fine-tuning examples from the compendium, that long, brutally long list, is because it has theological significance for us. And here's some things that begin to have theological significance on us. In let me see, what's the date of this book? 1968, this guy named Eric von Daniken, which my dad actually had this book. I remember we had it on our bookshelf when I was a kid. It involves the hypothesis that the technology, it's called Chariots of the Gods, by the way, so the one we're looking at. It involves the hypothesis that the technologies and religions of many ancient civilizations were given to them by ancient astronauts who were welcomed as gods. And he used biblical examples to try and prove his theory. Interestingly, the first draft of the publication was not well received and was rejected by a variety of publishers. But the book was extensively rewritten by a guy named Wilhelm Rogersdorf, which was a pen name for a German screenwriter named Wilhelm Utermann. Wilhelm Utermann was a Nazi best-selling author and held a leading position with a Nazi propaganda paper. And so, does that tell you anything about the work here that he did in this book? Obviously, he's a propagandist. So, the next book, though, that was written, that was really a huge seller that has impact on our discussion, is The Spaceships of Ezekiel, written by Joseph Blumrich, about a spaceship that was observed supposedly by the prophet Ezekiel. If you go to Ezekiel 1, you can examine the description of Ezekiel's vision where he's called as a prophet, and you can compare it to what Blumrich wrote. He's a chief NASA systems layout branch in the program development office at the Marshall Space Center. In fact, he read in Daniken's work from the Chariots of the Gods, and he wanted to go, supposedly, Blumrich decided to disprove Daniken's hypothesis on Ezekiel, but he was so compelled that it really was a spaceship that he wrote it and drew a picture of it, and that actually is the picture of Ezekiel's spaceship, supposedly. Let's see. So the reason we bring that up is because, did God create life elsewhere in the universe? He could have, because if you believe like I do, he's a pretty powerful God because he created the universe. So it's certainly possible that he did that. But at least from the evidence that we've looked at tonight, it doesn't seem very probable. It seems a little bit out of the realm. So we go back to our UFOs because there seems to be something there still. But the extraterrestrial hypothesis leaves us wanting both biblically, I think, and scientifically. So there's another hypothesis, and it's called the interdimensional hypothesis. And it has a subset called the extra-dimensional hypothesis. The interdimensional hypothesis, for the most part, is looking at people or beings from parallel universes entering our universe. Unfortunately, general relativity dictates that once physical observers exist in a particular universe, and don't ask me any questions about this, please. General relativity dictates that once physical observers exist in a particular universe, the space-time dimensions of any other hypothetically existing universe could never overlap the dimensions of the universe containing the observers. So if you're in one dimension, or if you're in one parallel universe, you cannot enter into another universe. But now, the extra-dimensional hypothesis is very interesting for our purposes. If we look at Hebrews 11:3, it says, "By faith we understand the worlds were set in order at God's command, so that the visible has its origins in the invisible." Because even with the science that we have today, it's relatively easy to realize that there's a dimension beyond the one that we know about. I think we could probably, most of us, agree to that. Because if the Big Bang is real, and there seems to be a mounting body of evidence to suggest that there's a good possibility that it is, then time, matter, and space all had an origin. But what came before that origin? And that is the dimension that we would be looking at. So I think we can pretty readily assume, and from this verse in Hebrews, I think that we know that the universe was made transcendently. It comes from a source that exists apart from matter, energy, length, width, height, and time. Something beyond that. So there's some theological implications. If you're unconvinced by some of the evidence that goes against the extraterrestrial hypothesis, you can still believe in the authority of Scripture and embrace a Christian worldview. One may argue that a creative God of unimaginable power should not be expected to limit his creative expression to just one planet. So if you want to believe in the extraterrestrial hypothesis, I say good on you. If we're alone, though, which that seems like the evidence that we're seeing, at least as far as the creatures that we know, if we're alone, and God created the entire universe and fine-tuned it just for us, how amazing and gracious is our God. If one concedes that EDH is fairly easy, if one concedes that this extra-dimensional hypothesis is true, it's fairly easy to connect the biblical worldview to an explanation of visitors from somewhere other than Earth. This perspective seems to allow the greatest correspondence, I think, between science and Scripture. Sorry, I flubbed that one up. And I think this is Gabriel. Do you want to come up and give this quote?
All right, I hope you've got it written down.
I do.
This is from Paul Davies, who is a skeptic and agnostic, but says a lot of things that I like to read. He said, the cliche that life is balanced on a knife edge is a staggering understatement in this case. No knife in the universe could have an edge that fine.
That's very good. And in conclusion, I would like to read again from Psalm 19, which I read the last verse as our opening prayer. And I'd like to read the beginning of Psalm 19 for you. The heavens declare the glory of God. The sky displays his handiwork. Day after day it speaks out. Night after night it reveals his greatness. There is no actual speech or word, nor is its voice literally heard. Yet its voice echoes throughout the earth. Its words carry to the distant horizon. In the sky he has pitched a tent for the sun.
Can I say one thing?
Surely.
In my mind, I used to believe, oh yes, there are life forms everywhere.
Yeah.
I don't believe that anymore. But if God did truly create other life elsewhere, I think he would separate us by such distances or universes, whatever you want to call them, that we'll never pollute each other.
That's absolutely right. I've often quandared that possibility of running into extraterrestrial life forms, but I don't have that quandary anymore. And Hugh's book really puts that argument to rest, because he makes the argument so strong against any possibility of extracellular travel or even intergalactic travel that it would be virtually impossible for us to have any contact with any other beings in the universe, no matter what, because the universe is just far too dangerous for one thing. You just could not ever survive the trip. And so Hugh makes a very strong argument, and I took a 10,000-foot view overlooking a lot of what I read in some of Hugh's works that we didn't cover, and that's exactly one of the points that he makes. But not only that, but it just has weird theological ramifications, right? Sinful people with some other race that is maybe not, or whatever. It's strange.
A couple of points. The Big Bang mathematical model indicates that the universe was created in 9 spatial dimensions initially. 6 of them curled up to Planck length, 3 expanded through good expansion. So there are other dimensions existing in this universe.
That's right.
And secondly, that the energy for the Big Bang came from outside our time and spatial dimensions, because they did not exist. They weren't just empty. They did not exist. So
right.
God at least exists, we know, or can exist in other spatial and time dimensions. And he crossed over and made ours, if you will, which relativity says cannot happen otherwise.
That's right.
A couple other things relative to UFOs. There's a book I read once that had photographs of Nazi advanced weapons at the end of World War II, including some flying saucers. Small, they were about 10 meters across, with jets on the side. It was thought that they escaped with some scientists to the Antarctica at the end of World War II.
Oh.
And there's a document from Truman ordering Admiral Byrd to take an expeditionary force to Antarctica to find out that. The only thing, the rest of the document is blacked out, it's still classified. Byrd came back and said that there were heavy casualties. That's all that's said in the document. All the rest was blacked out. So you could make the view that the U.S. got that stuff, because you can, they've got pictures of the captured flying saucers, which have jets around the side, if you will. The other thing is relative to still the biggest one out in New Mexico. If you read all the witnesses as to what they said, the ranchers and everything found, what they found is far different from what the government ever said. You know, this weather balloon stuff, right?
Yeah.
As far as metal parts and all that sort of stuff, including strange bodies and all that. The witnesses have been pretty coherent and fairly consistent on what they said, and it's far different from what the government ever said. So whatever happened, whatever crashed there, it could have been government-owned or whatever, but it certainly is.
They go into some pretty good detail in this book, and there's a guy named Mark Clark that actually talks about some of that. And some of the reason for the suspicion on the government, for one thing, is sometimes a lot of these black ops sort of projects will have, they're a need-to-know basis, and so you have one person saying something over here, they don't have any idea what's going on, and so they may make comments, and then another guy over here saying something, he may not have anything, know what's going on, and he's saying something totally different. Then you got another guy over here who may know something that's going on, but he can't say what's going on, so he says something totally different, And so what you have is a lot of conflicting stories from the government, too, that adds to the confusion and suspicion, and so. And we didn't even really get into the extra-dimensional beings that Hugh talks about, because he believes that most of these are UFOs, which he does say that there's really credible evidence for these, the existence of encounters with alien beings and sometimes things that affect the physicality of this universe. But obviously, he believes they come from the spiritual realm, and so you can imagine what.
Yeah, I was going to say, I think that we have been visited by extraterrestrials. It's just not space aliens.
Right.
Well,
And that's what he says.
I heard a lecture once by Lear of Lear Jet Fay.
Oh.
Fairly credible guy.
Yeah.
Who spent a lot of time taking movies in Area 51 back in the late 60s, 70s, and 80s, and 90s. And he's got these fantastic movies of, right angle turns and all this sort of stuff. And nothing I've ever seen come out of skunk books or anything else can match what these are. They're not searchlights or anything like that kind of thing. But at the same meeting, there were 3 women who claimed they had been abducted by alien spaceships and sexually assaulted.
Yeah.
And one guy asked them a question, and the answer he got was so disturbing, and we avoided the rest of them. And then the rest of the evening, they were seriously disturbed women.
Yeah.
But I mean, nobody wanted anything to do with them. Convinced that they had been sexually assaulted. So it was a very, other than that strange part, that their stuff is really very interesting.
That is. One of the things that is a mark of these RUFOs too is that they do not have to obey the laws of physics. A lot of times, they can do things that go against the natural laws, and so. And if they were extra-dimensional beings, we would expect them to be able to do things, and that would also explain the extra-dimensionality of perhaps maybe Christ's ability after his resurrection to be able to do unusual things like walk through locked doors and not obey necessarily the laws of physics. So.
What book were you reviewing of Hughes?
Well, I went to several different sources, but the one I really relied on the most, because I thought it had the best information for what we were going to be talking about here, was Lights in the Sky and Little Green Men. And it was really, I've been wanting to read it for years. I made my son read it a few years ago for a project he was doing in school, but I have a stack of books this tall that I want to get to, and so it's everything gets shoved off to the side for whatever's the most pressing, and so I had the opportunity to do it here, and so it was a great book.
Yeah, I cracked the whip over him.
He did. He was. Other questions, comments? I thought there'd be a lot more lively discussion tonight with such a strange thing. Has anybody ever had an encounter with anything? Like mine with the light. The funnel, it was a funnel of light that came out of nowhere. I mean, literally, there was nothing there. There was no noise. I always kind of think, was it a helicopter? I couldn't hear. There was no, a helicopter, you would have been able to hear something.
You ever figure out what happened to the animals? Why?
I read about that, and it looks like a lot of the so-called cattle mutilations were natural deaths, and they, at least some of the evidence points to the fact that just natural decaying process could even make things look, as they bloated, it could make it look like surgical cuts in the hide, and carrion birds would take out things like would eat like the rectum and the eye because they're soft tissue. I know. But, so anyway, yes.
I did see some strange lights a few years ago. This was in Marfa, and we were watching the lights one night, but it was from a winery, and after a couple of glasses,
They
That's
start to
great.
float up and make right angle turns.
I started seeing 3 or 4 all of a sudden.
No, he doesn't have enough. He doesn't need
Yes.
those green men.
Did Ken did he contribute to that book
He
also?
did, yeah.
I think the
Three authors.
theological aspect would be really interesting.
Yeah, he talks. They didn't talk as much about that as I was kind of hoping. It was kind of just a sampling right at the back, but throughout it, there's a little bit of theology as you go throughout the whole book. So
There was all sorts of issues. Okay, there's other alien life. Did Jesus visit them?
Yeah.
Yeah.
Die on the cross with them too?
Yeah.
I mean,
He
that
couldn't
just
be their
gross.
kinsman redeemer.
yeah, that's right.
Right,
Yeah.
and the scriptures say that Christ died once and for all.
Mhm.
And so if there's a planet somewhere else with civilization on it, you have to say either they somehow are able to get in on this salvation by some theological system that we can only guess about. They are unfallen and don't need a savior, or maybe they're like the fallen angels, where they're fallen and they just are not given any opportunity for redemption. So, I mean, any of those are possible.
In that scenario you mentioned about if they were perfect and we somehow made it there and there was a risk of contaminating them.
Yeah, right.
And sin and everything. And I read
Yeah.
a book when I was a kid. I was 14. It was called The Second Conquest, and that's exactly what it was about by Louis Duval.
Oh, really?
Yeah,
I read that.
very interesting.
I think the part of theology that speaks most directly to the question is, what is the purpose of this creation at all? Why are any of us here? And I think that the fall and redemption are part of that. That it's God showing what happens when people fall. It's creating people that fall and can be redeemed, who can live forever in heaven without polluting it, who have this knowledge of what it's like to be on the other side. It's like people who've been through a near-death experience. They have a certain perspective on things that you can't get if you're immortal,
And that's Hugh's perspective, I think. He
Yeah.
went through that because he is saying God is. This is a big experiment's not the right word, but to do away with sin, God's plan to do away.
Right,
with
so the
sin.
question is, how would another civilization fit into that plan? And if it doesn't fit in, there's no reason for us to think that God did that. And I think there's also no reason to think that because space is so vast that something is wrong with the creation if it's not full of other civilizations. Because if you look at some of these parameters for the galaxy and the fine-tuning of the universe, it all has to be there if God is going to make even one planet anywhere that can support life, given God's normal way of operating, which is he carefully defines laws of physics and generally operates within those. And he uses the sort of natural evolution, the rolling out of those laws over time to do his bidding. And so, for instance, one of the biggest fine-tuning parameters that we have for the universe is the mass density. And if Hugh was quoted as saying that I think he had an article one time called "A Dime's Worth of Difference." And basically, if the universe started out with 1 dime more or less matter in the whole observable universe, that's 1 part of 10 to the 60th, that it would change the way that the mass distributes as the universe expands. And if there's a little bit too much mass, it clumps too efficiently, and you have nothing but black holes and neutron stars all over the place. And if there's a little bit not quite enough mass, it spreads out too efficiently, and you wind up with nothing but these big spread out nebulae, and nothing gathers together to make rocky bodies. And so, if given this is how God chose to operate, obviously he could have poofed it in there all at once, but he wanted a history. He wanted things to roll along that way. He needed all that stuff and all that space to make this one planet work.
That is mind-boggling, isn't it?
Well, it
and
shows,
by the
his,
way-
it shows his
God.
grandeur.
Right.
I mean, and I think it's part of his, it could be seen as part of his perfect plan to limit sin to a very small area and do away with it.
Yeah, you can almost see all this empty space as sort of like a quarantine zone.
So God must have been a pretty good engineer.
That's
Yeah.
right. He must have been pretty decent, huh?
Yeah.
Yeah.
But later on, we took this course for the advanced astronomy and science, and they talk about inflationary
Mhm.
Big Bang. Basically, this one dime can actually achieve by the inflational model,
Mhm.
because it goes through this inflationary period. Actually, after that, the density of the universe must be exactly right. So basically, I mean, the inflationary process can make the mass density super accurate.
Mhm.
That's,
Yeah, there's been I think that may be one of the reasons that there's 2 fine-tuning parameters that are not included in any of these lists. There's the mass density and the space energy density, which has to do with the geometry of the universe. And because they're kind of out there a little bit. So yeah, it's possible that something about inflation actually drives them to what looked like a
it's
fine-tuned
the way
parameter.
God made it
But
be super accurate.
when you start looking at those theories that show that there's a process that makes it look fine-tuned, that process itself has fine-tuning, and so it doesn't really, it would look like, if you put that out there saying the universe is fine-tuned, it would look like you're having to retreat and say, oh, well, maybe it's not. In reality, you're saying, oh, well, you're just replacing one fine-tuning with another. Let's, after we understand that, we'll find out that it's even, it's 10 to the 70th instead of 10 to the 60th to get that to work.
What's the theories on why it's necessary to have the 6th dimension that remained wound up and never got unfurled? Do you know why that would be necessary?
I believe it has to. It's only predicted by string theory. Is that correct? It's string theory.
To make the Big Bang work, there's extra dimensions.
Yeah. Well, and to make the superstrings vibrate into these other dimensions. So it's something that was required to make the mathematics work, and it's not just an extra 6 dimensions. It's extra 6 dimensions that are curled in a certain weird geometrical shape. It's very specific.
And the humorous thing about all this is that no one, we've got all this idea about plumbable soup causing life, but if you look up, go to the internet search and find out what is the definition of alive, you will not get a consistent definition from anybody.
Mm-hmm.
Yeah.
And secondly, no one's been able to demonstrate experimentally with mathematical models or anything how a bunch of inanimate chemicals suddenly become, quote, alive.
Mm-hmm.
So,
Oh, yeah.
they don't, so we're talking about life elsewhere, they can't figure out how life started on Earth.
Right.
Well,
Chemical
and
evolution is a big problem.
Yeah, and they like to speculate about, well, maybe it could have started there, maybe it could have started there, but they don't have any set of conditions that they say, if only we could find these, maybe life could start. Because they would just reproduce those in the lab and show that it does. But they can't. And as Fuzz has pointed out, there are various components that would have to come together at the same time to make the RNA or a protein or these minimal self-replicating systems, where you have 2 components. One requires certain conditions as far as like the acidity of the material it's floating in and the temperature and whatnot that contradict the conditions required for the other. So in other words, if you've got the conditions to make one set, you excluded the other set that has to be there at the same time. So now you're positing that you have actually several sets of conditions, all within close proximity, where just as they as the materials form that need those conditions, you jam them into this little neutral zone where they can combine together and have a membrane that protects them and all this kind of stuff. But yeah, you can take apart a cell, and no matter where you put it, something's going to break. It won't just sit there and let you put it back together.
Even evolutionists have, even conservative evolutionists have agreed that for anything like that to be possible, it'd be one chance in 10 to the 1,000th. And so that's a ridiculous number.
And then lose our government grants, you know.
Yeah, right.
Well, hence the appeal
But
to
that's,
multiverse.
this is that, so you're telling me there's a chance.
Well, I was going to give you a number even more ridiculous. I went and did some reading. I found the documentation of the simplest form of self-replicating living thing. And there's some question about whether or not it could even survive by itself. But take the size of the genome and then go and calculate the probability against that being formed by chance. And it came out to 1 in 10 to the 320,000th power.
So, you see what kind of numbers we're talking about here? And 1 in 10 to the 50th, remember that number.
Yeah.
1 in 10 to the 50th is 0. That means never, no matter, if you had infinite time, you could not make that happen.
Yeah, and something to keep in mind.
They're like 10 to the 80th elementary particles in the observable universe.
Yeah, I was going to
Every,
say.
every electron, neutron, and proton added up. And those are just elementary particles. That's not even atoms.
Yeah.
Yeah.
So you take that and you multiply that by the positive age of the universe and just be generous and say it's a trillion years. You know, then that's only 10 to the 12th.
Yeah.
That's 10 to the 92nd. And you say, okay, maybe 10 to the 10th times per second, you can get a reaction.
Yeah.
And then you're only taking 10 to the 102. I mean, the number, the improbability for the simplest form of living thing that we observe today is such a big number, I can't even wrap my mind around it.
Yeah, right.
Yeah, so like with these parameters in the design compendium, if you look at just the parameters affecting a planet or the planetary system, you get fine-tuning to within 1 part in 10 to the 300, say.
And that's added on top of the improbability that I was just talking about.
Yeah. Yeah, this is just to have some place where we could manage to survive there if we brought all of our technology and people and
that's
budget.
just to get the lab where you could do the experiment.
And a lot of people say, well, but space is so vast.
Oh, yeah.
But not that vast. I mean, the estimates.
Mostly empty.
Yeah. Well, but
and what's
the
not
number
empty is hostile.
Yeah, right.
But there may be 10 to the 22 planets in the observable universe. That's where you got this universe size. The observable universe is about 30 billion light years across. Now, the universe could be infinite beyond that, for all we know, but as far as anything that could ever affect us, that we'll ever know anything about, it's just the observable universe. There's 10 to the 22 planets. Maybe we're way off, and it's 10 to the 23. I mean, that would mean 10 times as many planets as we ever thought. That's dwarfed by these 10 to the 300 kind of numbers. In fact, when in the calculations, when Hugh and the rest remove that, it's like, well, the number hardly changed. The vastness of space is minuscule compared to this.
We got any questions online?
I have not seen any. I've gotten feedback from Bob Stewart, Bob Clapper, and I think at least one other RTB person have been watching it to see how the Periscope stream looks.
Were they able to hear without these guys being mic'd up?
Yeah, they said the audio is fine. Well, I was actually able to look on I've been able to monitor it on the laptop. It's got a little bit of a...
Mine died right at the very beginning, so.
Oh, it did?
So we didn't
Yeah. I had extra batteries and they're all dead.
Clapper and Stewart both asked, what camera did we use? And I said, iPhone 5S. And they asked why the image is so stable. And I said, you can get an attachment at Fry's to put it on a tripod. So some people within the RTB organization are kind of monitoring us tonight to see how this works. So
We should be on our good behavior.
well,
Yes, the
I
camera
think a lot
mount
of
is
people-
fine-tuned to within 1 part 10.
A lot of people are interested in this Periscope and other ways to really inexpensively broadcast, within our budget, which is nothing.
Right. And that's what it costs. So, match made in heaven.
What do you make of this, David? Saying to you, I will give the land of Canaan as the portion of your inheritance, when they were few in number, just a very few, and resident aliens within it.
There it is.
There it is, your biblical evidence.
Wow. Yes?
Recently, I have been discussed with some RTB apologists about this Earth size need to be very accurate, and I didn't get a real affirming answer. And my impression is the Earth size. I mean, previously what I learned is that the methane and the ammonia has to escape, okay, and water has to stay. That's how the Earth size was decided. But later on, I heard some complicated arguments say that actually ammonia and also methane actually mostly stayed as well. But because the Earth has oxygen, so they actually oxidized, they actually didn't escape. And water it's only the helium or hydrogen that actually escape. So it actually is complicated. So the Earth size has to be that accurate, seems like. And I tried to find some more research saying it has to be 1% accurate, and I couldn't find it anymore. So and that's just
well, this list is about 6 years old.
Yeah.
And every time they update it, they add, remove things, change the fine-tuning degree. Of course, every time they do, the total fine-tuning goes up, even if some of the things have dropped off. So yeah, there are, and of course, part of it is that there are, like you could say, well, the Earth could be 5% larger as long as you also have something else that would compensate for it. And that is removed from the probability calculations as dependency factors. So, and actually calling it a probability is a little bit kind of a loose term. It's not, because in order to call it a probability, you have to know what range of guesses, you can't, if I say, hey, I've got I rolled a 6-sided die, and I'm going to say there's a 1 in 6 chance that I'll roll a 6. Well, in order to do that, you have to know something about the die. You have to know how else it comes up. And in a lot of these cases, we don't know, especially fine-tuning of the universe. We don't know. I mean, it looks very particular, but I mean, how do the dice roll? So what it's actually telling us is how small is the habitable region within configuration space. So if you take all these parameters, 800 something, and plot them all on a separate axis, there's what we have here on Earth is one point within all those where we know everything lines up. But we know that we could also, like for instance, the Earth could be a little bit further away from the sun and have similar weather if we just had more greenhouse gases and maybe a few other adjustments. So what that tells us is that this little habitable region in configuration space is, and configuration space is a mathematical concept, not real space. It basically means that, yeah, so if you can actually draw a line off of our point a little bit in one direction, it's still habitable. But the real question is, and what this is kind of telling us, is that the total volume of habitable configuration space, with all the adjustments that would make this huge lattice work that could go all over the place, including a lot of really exotic kind of worlds, is that they all have to be fine-tuned within very narrow parameters. And the fact is that there's a whole lot of uninhabitable space where, in any case, you could move just slightly off and boom, nothing lives.
Yeah, as far as Earth size, I would think at a minimum you'd have to have a mass sufficient to retain water. But if the mass became too great in the atmosphere, as I understand, is one problem. It becomes too dense.
Right. Well, and actually the Earth is over that size. Because the presumed density of the atmosphere that forms through normal planetary formation is based on the mass of the planet and the distance from the star. So the closer you get to the star, the more of the gas is essentially driven away by the solar wind. So the fact that the Earth is slightly larger than Venus and further away from the sun suggests we should have a thicker atmosphere than Venus. And so as the theory goes, we did have a thicker atmosphere than Venus. But thanks to this Mars-sized collider that formed in a nearly identical orbit as the Earth gradually caught up, or we caught up to it, and collided and actually blasted away all of the atmosphere. So the relatively thin atmosphere we have now is the result of outgassing. So we got a whole brand new atmosphere that doesn't follow any of the rules of planetary formation.
Very nice.
Gentlemen, I have a question right quick.
Okay.
Is it okay with you if I continue to watch reruns of Star Trek and Star Wars?
Absolutely.
Yep.
I'm there with you.
Okay.
That's why I said I'm sorry to be the wet blanket. 'Cause, you know,
Brian Rohrenbacher is like the biggest
Yes, of course.
Star Wars nerd in the universe.
Now-
you guys know Brian? What is his title?
Chapters manager.
Chapters, yeah, chapters manager.
Now
He
there are-
posted a picture of his opening night pictures, of his opening night tickets. For,
Oh my gosh.
Force Awakens.
Has everybody else got their tickets for Star Wars? Me neither.
There are science fiction, universes where there aren't any other life forms. That there are people going around spaceships visiting all kinds of weird creatures, but they're all just humans that have colonized other worlds ages ago. So you can still get interesting sci-fi without aliens. It's just
Star
only
Trek
art.
did
Firefly.
they had an episode, I think, with silicate creatures, didn't they?
Yeah.
I think, didn't they?
Aliens or something.
No,
There was a
it's
rock.
the rock.
That
Yeah.
had all these incredible powers. But somehow missed some fairly simple
See, that's
moral
good.
principle.
That's good science.
I would think that if you had some creature from another dimension showed up here, wouldn't they be pretty much stuck with the laws of physics as
Nope.
we consistently observe them here on Earth?
Well, it depends. I thought of that. Yeah, so they would have to kind of follow our laws when they're in our country,
Yeah,
but
that's right.
it depends on what they are and how
when
they
in
get here.
Rome, do as the Romans
That's
did.
right. if they are physical beings, that's right. When in fact physical beings couldn't make the trip ever, it's impossible. And you're right. How in the world would you even conceive of moving? I mean, it's like
How would you interact with the material world of our dimensions?
right. It's not even a practical problem. Like it wouldn't work. It's like how does it even make sense? You've got another parallel universe with whole different laws of physics. How does it even translate over?
Yeah.
Well, don't forget, angels do that periodically. And
Right,
they
but
do
they
live
are
in
not.
a different dimension.
They are not
Different
physical
realm.
life.
No, but they
But-
can
but
take form.
Yes.
But that's a
Physical form.
dimensional issue, not a.
Well, the parallel
Parallel
universe,
universe
and separate
issue, that's
dimension.
different.
Yeah, that's a different definition of the word dimension. We're not talking about
Yeah.
length, width, height, time, and dimension X. We're talking about
Yeah.
some kind of a parallel existence that is not just another universe spawned from the same multiverse that
Right,
is
yeah.
ours.
One of the early Star Trek episodes that I remember so well, they visited a planet and they observed this planet was full of sun worshipers. They got to the end and they found out
I've
it's
seen
not
that.
S-U-N, it's S-O-N.
Yeah.
And Jesus had appeared there.
Ah.
Which
Yeah, and
we
they're
don't know if
killing
that's
Missed
ever
that.
happened,
they're
but-
killing believers in a coliseum. Only it takes place
Right.
with like 20th century technology.
Exactly.
So they're televising
Yeah.
the coliseum tortures and
Hilarious.
yeah, that was a really fascinating.
You guys have
episode.
just never seen Walter's universe window.
What?
Yeah, you guys have just never seen Walter's universe window, where you can peek into the parallel universe with his window.
What is that? I don't know what that is.
Do you have it in your garage? Can we come by?
I thought it was a sci-fi reference.
It is.
It
to
is.
Fringe.
To who?
Fringe. It's an old sci-fi show.
I don't know it.
Yeah, Walter.
See?
It's on the Fringe.
It's on the Fringe.
Okay.
Other than sci-fi, it's not that old.
There are 10
Well,
to
no, but-
1,000 different sci-fi.
Yes, there are. You're exactly right. You're not kidding.
All with contradictory laws of physics.
My question was kind of talked about already, but I was going to ask about the extra-dimensional UFOs and what the theories are and what that is, and if an angel would count as that, or
That's where Hugh's going with his
I think-
whole work, is because he's basically using he's looking at the science and he's saying, look, this is this really, I mean, this extra-dimensional hypothesis really matches up well with the biblical account, and all the others don't. The extraterrestrial hypothesis, as you can see, just leaves you thinking, no, that's just not. Once you start really looking at it, you think that's not going to work. And then this other one with the parallel universes, you find out, well, the science just isn't going to fit with that one either. The problem is we have a big problem with naturalism, because naturalism has a flawed assumption that goes along with it, that there is no supernaturalism. So you can't add that in to any sort of naturalistic explanation of anything in science.
But they kind of, when it comes to that sort of thing, like interdimensional beings, whatever, they kind of blur the lines, because they would, I've encountered people who agree that, yes, the universe had a beginning, transcendent beginning, there's something beyond the universe. But what they want to do is say that whatever's beyond the universe is enough like what we're used to. It's a universe of matter and energy and, at least marginally familiar things, and that somehow gets them out of calling it supernatural, even though that's kind of the definition.
That's
So-
what
so they-
J.
in order
Warner
to be-
Wallace addresses that, though,
Oh, yeah?
and basically says all you're doing is you're just adding another layer, because where did that one come from?
Well, with that
Yeah.
kind of reasoning, it's a obvious contradiction of the law of non-contradiction.
Yeah, right, exactly, right? That's right.
If it had a beginning of matter and space and time, anything on the other side is not material.
Right. So you could I think it's valid to say, if it's beyond the universe of matter, energy, space, and time, it's not nature, it's supernature.
Mhm.
And if you're going to assent to that, then you are no longer in Carl Sagan's camp, where you say the universe is all there is or was or ever will be. You are in the camp of the supernaturalists. And then the question is not, is there a supernatural? It's what is the nature of the supernatural? And the main reason that we would even, the reason we postulate the supernatural from a scientific perspective is it has to explain this universe. That's why we're even going there, looking for an explanation of this universe. So whatever the cause is, it has to be sufficient for everything that we see. So it has to transcend the space-time manifold of the universe.
Mhm.
It has to be capable of carrying out cause and effect kind of things without cosmic time. So it has its own timeliness.
Mm-hmm. Has to be intentional.
It has to be intentional, because it happened.
Mm-hmm.
And when we look at all the fine tuning, it looks like it has to be intelligent. It has to be thinking or something like that. And because the only force that the kind of thing that we can imagine or that we've experienced with that is intentional and intelligent and plans things and fine-tunes things is also personal. And that also is important, because it explains how intelligences and people wind up here. I think that's a major problem with atheism. It says that you have just interacting forces out there that lack all these properties of intelligence, forethought, design, care, all these that are associated with people or personhood, somehow made us that has all those characteristics.
And from mindlessness, it creates mind.
Right.
It's amazing.
You wrap it up?
It's miraculous, if you know what I mean.
Wrap it up, Phil. Wrap it up.
So what we're talking about is a cause beyond matter, energy, space, and time that is personal. And so now the question is, what's the name of the God? Not is there a God? And you're into the realm of theology.
And we're in the camp of the biblical God.
If you're following where it goes.
David, I want you to shut up. You want to close this out?
Yeah. Heavenly Father God, we are so in awe of you, Lord, for your creation. And we thank you that you've given us minds that are able to wonder and to ask and to process. Lord, we don't come up with the conclusions. We don't come up with the answers all the time, most of the time. But Lord, we are thankful that you we know you love us. We know that you created this for us. And Father, we just pray that you will help us to be lights for you in this world, on this earth that you've given us. Thank you for this time tonight, for the ones that have shared, and those that have just prepared so well, God. I thank you for that. I thank you for the new insights that we have. May it glorify you in Jesus' name. Amen.
Amen.
Thanks a lot. Great job, guys.
Thank you, guys.
Next meeting is December 9th.
Are we having a Christmas party?
We
Is
can
that
make
it?
it a Christmas-themed event. We may have a guest speaker we're working on with
Bishop.
Yeah.
Bishop, as far as I know.
Neuroscience.
Right.
Yeah, last I heard from the email trail, he was saying that he could make that time, as long as the home office
Yeah, we
give us the
had-
paperwork.
Yeah, we had some
What's
snags.
that talk on? It's on
It's on neuroscience,
neuroscience, yeah.
and he asked me last week, was he supposed to be?
Get together and talk.
I've been a little slow to respond to email. My wife and I got licensed for foster care about a month ago, and our lives have been turned upside down. So if it takes me a while to respond, it's not that I'm not trying to. I'm just, it's been crazy.
You have kids, though.
Yeah.
We have 2 kids, yes, plus the one we already had. Yeah, it's been interesting.
3 in your house?
We have 3 total, counting the one that's actually ours.
Come back for a Christmas party.
How old are the other 2?
One is turned 4 today, and the other one is 5.
Oh, wow. They're all about the same age.
Thanks, everyone. Bye.
Now, you know they do